Okay, cool. I think we should be live. Thank you guys for joining. Super excited to be here today to talk to you guys about building on Ethereum with Scaffold-ETH. I hope you guys are enjoying Hack on Chain. Quick introduction, my name is Kevin Jones. I am a Solidity developer and an advocate for Scaffold-ETH. Really excited to talk to you guys about what Scaffold-ETH is and how it can kind of be a great resource for you guys building on Ethereum, and especially for a hackathon project. It's just a great starting point for that. So let's go ahead and share our screen here. And we're going to bring up just a couple slides just to kind of go over and kind of set the stage for what Scaffold-ETH is and how you can use it to get started with your project. This is all my contact information. So if you want to connect with me on Twitter or any of my other channels like Telegram, if you have questions or issues afterwards, let me know. Full-time, I work for Nginx. It's the #1 most used web server on the internet. But I also am an advocate for Scaffold-ETH, and I'm really just here to talk to you guys about what Scaffold-ETH is, how easy it is to build on, and get started. So there we go. So Scaffold-ETH really is kind of a toolkit that comes with a lot of different things that you need to get started. More importantly, to get started, these first three things are kind of what you're going to need on your system to be able to follow along with any kind of demo that I'm going to be doing today, or to get started on your own. Obviously, you need Git to be able to check out the repository. You need a copy of Node.js 16 or higher. The most current version is 18, so I would recommend that. And then you need a copy of Yarn Package Manager. Yarn Package Manager is essentially the package manager that you use to orchestrate all of your commands, and it comes with all of the configuration dependencies, so you can just do one simple command to set up your environment using Yarn. So yeah, Yarn's a great resource, and really pretty much everything revolves around Yarn with Scaffold-ETH. What you do in the Yarn install, it's going to install Hardhat for you. Hardhat is like a virtualized Ethereum virtual machine that runs locally on your laptop, and it gives you an entryway into like a test net or mainnet. And then it also installs React for you, and it's going to start that up for you on port 3000. And then everything we're going to be doing today is going to be around Solidity. Okay, so I'm going to kind of show exactly how you like start building your smart contract in Solidity, compile it, and kind of what Scaffold-ETH provides to you for this kind of orchestration of your Solidity smart contract. Okay, so if you're a developer, you can clone the repository. Really simple. You do a Yarn install. That's going to install all of your dependencies for you, and that's going to get you set up. You just do that once and you're good. Yarn chain is going to spin up your blockchain. It's going to spin up a copy of Hardhat. Really simple, one command. Yarn start is going to spin up React for you on port 3000, and Yarn deploy is going to deploy your smart contract to Hardhat. And as you start interacting with your application, the blocks will form and you can start kind of testing your assumptions. Okay. So if you get an itch to learn more and you want to kind of start building on Ethereum after the hackathon, the one takeaway I will say is go to speedrunethereum.com. Speedrunethereum.com is going to take you through some challenges and kind of test your ability to write smart contracts and to deploy applications on in a decentralized way. And it's a great resource. And eventually you'll actually get invited to the Build Guild, which is a group of developers that are building on Ethereum. So go to speedrunethereum.com after the hackathon, and that's going to be a great resource for you. If you get lost along the way, there's a Telegram channel, there is a docs page. This is a link to all of that stuff. So you can scan this, save this as a contact in your phone, and it's going to give you all of those links. You can also just Google search Scaffold-ETH Telegram, or you can just go to Scaffold-ETH's GitHub, and a lot of the links are already there. But this is kind of slick. It's just one simple contact card. Okay. All right, so let's get going. No more slides. We're going to talk just, kind of straight demo style. If you do a search for Google on Google and you do a search for Scaffold-ETH, the first thing that's going to come up is going to be the GitHub. Okay. All the instructions for getting set up are going to be down here below. They're going to talk about everything that I just talked about and everything that I'm going to be doing here kind of in this demo. But really, yeah, it's going to clone the repository, do the yarn install, do the yarn chain, do the yarn start, and good to go. And then this is going to walk you through kind of those instructions of how you can edit certain parts. My goal today is to show you a full walkthrough of how you deploy a DApp and build a DApp kind of from scratch, okay? So I don't have everything running right now, but I have gone ahead and installed, I've checked out the repository here. So we have that. And I've also gone ahead and did the yarn install. So I went ahead and did yarn install, and I've already pre-installed all the requirements. When you first check out the repository and do the yarn install, it takes about 1.5 minutes to do that stuff. So I just saved you some time, but we're good to go. So now in this first window, so you'll notice I have 3 windows open. With Scaffold-ETH, you kind of always have 3 windows open. And that's because your first window is running a copy of Hardhat, and it's going to have some console logging that you can output to. And so we want to keep that open, okay? The next window in the same directory, we're going to do yarn start. That's going to spin up a copy of React, okay? That also is going to take about 1 minute. So you're going to want to just kind of let that sit. We can come over here and we can see that it's starting. But more importantly, we're just going to let that run, okay? So those 2 windows are always kind of open, and they're kind of just like you're just watching those for like console output to see if there's any issues with like React or with Hardhat, or if you're doing some kind of logging, you can log it to Hardhat as well. So we can see here now that we got some calls because our front end started to our Ethereum blockchain. But what we need to do now is do a yarn deploy, okay? So we're going to do yarn deploy. Type correctly. Okay. Yarn deploy is going to take a smart contract that's there and deploy it to Ethereum virtual machine. And we can see that it was successful. And we can see that the transaction, and we can see that where it was deployed to, what the address is. And we can also see how much gas was used. So anytime you deploy a smart contract, you need to pay the gas. And so it uses some gas that's built into Hardhat to do that. And we paid for the gas deployment, but it told us how long, it told us how quickly it did it. And we also did a subgraph deployment, which is for the graph, which it does come included with Scaffold-ETH. And it just shows you what the Hardhat command is. But it's really nice because we can see the contract calls here that we're logging. But now let's go ahead and take a look at Scaffold-ETH. Okay, so this is what Scaffold-ETH looks like from a UI perspective. You can see here there's like a little nice toggle light mode, so you can switch between light and dark. The first thing you'll notice is you have all these tabs that you can kind of explore. The first tab that you're seeing here, everything here is kind of like where you'll build your app out. So as you start building like some functionality into your application, you'll put this into the home JSX file. So it tells you right here where the path is for that inside the project, and you can start building out any functionality in here like your UI, okay? But the magic sauce is actually here in this debug contracts folder, which is really great for when you start prototyping building a dApp, because you want to be able to test your assumptions. And so you want to be able to make some changes to the smart contract, come over here, try to do some kind of message or transaction and see if it's successful and see how the app is working, okay? So you'll see here that we have the contract, we have the address for the contract, we have a value, which tells us if there's any value in the contract. We have a variable, and then we have a purpose. So I can come in here now, I can change this purpose to hack on chain like this, and I can hit send. It's gonna tell me like, okay, well, I want to make this transaction, but I don't have any money. I don't have any money to pay for the gas. So the first thing you'll notice is up here, we have this wallet that comes built into the dApp. We're not connected to MetaMask. We could do that, but we don't have to. We can just use what's called this burner wallet. And this burner wallet is like a temporary wallet inside the browser. So if I open another browser window, and I still have access to that public key to that different on both of these profiles. And so it's an in-browser wallet. But if I come over here and do file, new incognito window, and then I come over here to localhost 3000, you'll see that now I get a new burner wallet. So here I have this kind of like green guy, and then here I kind of have this purple and lime green guy, right? So it's 2 different profiles, and we'll keep that open because we're going to use that in a little bit. But it's cool to see that we have different burner wallets for different experiences. And then you also see we have this button to grab some funds from the faucet. So I can just quickly grab some funds, and that comes from Hardhat. If I want to, I can grab some more funds. I can copy the address here, and I can go here to my wallet here. I can paste my address in, and I could get like $1,000 if I wanted to, or I could get it in ETH too. I can say I want, I don't know, 10 ETH or something like that. I can come over here and say, oh, give me 10 ETH. And it's going to take that ETH from Hardhat and send it to my burner wallet. So now I've got 10 ETH. I got $11,000. I am localhost rich. Okay, so I've got some money here, right? And now I can do this. I can make this change. So hack on chain, hit send, and then boom, I was able to update this variable using my call to the function. Okay, so yeah, so this is a real good way for it to debug. And so what we can do is let's take a look at the contract. Okay, I'm going to load up the entire directory structure for Scaffold-ETH here. If Adam will run for me. Here we go. I guess I downloaded a new version. Okay, so now we have a copy of our project here. Let me close up some of this stuff. Okay, and you'll notice that there's a packages folder, okay? And here in the packages folder, there's really two places that you're going to be hanging out when you're building your project. The first one is Hardhat, okay? And Hardhat's going to be like where you are dealing with anything related with a smart contract. And then the React app is where you're going to be dealing with anything that is related to the front end, right? So back end, front end. And then if you go into this contracts folder, we have a copy of our contract. So this is the Hardhat contracts folder. And we can see here that we have that same contract that's here available in the UI. Here is kind of what we're looking at here. So we have the building unstoppable apps, which is what we had before, which is just the string. And then we have an event. We have constructors empty, which is where if you're going to do something with a deployment, you put it into the constructor. You have a set purpose here that allows us to update that purpose. And we do a console log, and we do an emit of the event, right? And then we have some other like just kind of fallbacks and receive functions to receive ether. And we have the Hardhat console, yada, yada, yada. So I could come in here and I could make a change. So I could say building awesome apps like this and save that. And then I could come over here and do a yarn deploy again, right? And this time I'll do a -- reset. So I'll just force a new deploy no matter what. So I'll do yarn deploy reset. And every time I do that, I can get a new copy of the contract. So here's a new copy. I can do it again, and I can keep doing that, and that contract is going to keep getting deployed. But what's important is I made the hard-coded change, and we can see that it's here. And so we could do something else like this function that allows us to update the purpose that we're calling here also is payable. Let's just remove that for a second, save that, and then do another deploy, okay? Make sure it's successful, which it was. And then you'll see that the UI kind of changes a little bit. So we got rid of that function that allowed us to send value, right? So when you're sending a message on the Ethereum virtual machine, you send a transaction and you can send some data, or you can send some value, usually if it's a payable contract. So you can see we took away payable. Now it's just a normal function and doesn't have any way to receive value. So the UI changed. So let's go ahead and put that back. But it's just to show you that it's changing depending on what your smart contract looks like, right? So let's go ahead and reset again, and let's start building something a little bit more interesting into the app. Okay, let's start thinking about like, well, what would make for an interesting app? Well, one of the first things you'll learn about building on Ethereum is that you might want to set up access control. Okay, so let's do some like kind of janky access control. Let's grab our address here, and let's make a new variable in the contract. We'll call it's an address variable. We'll make it public, and we'll call it the boss, right? And we'll do that like that. And then what we can do is we can say, all right, well, in order to call this new purpose, we could say something like require that the message.sender, which is the person calling the actual function, is equal to the boss. Otherwise, say not the boss, something like that, right? And then we can save that. And then we can push out another change. You're going to play reset. Okay, cool. So now if we come over here, we'll notice we have this new variable that showed up, right? Which should match our private key here. So if I come over here to this new kind of like lime green blocky guy, and by the way, if I hit refresh, you'll see it's still inside the browser. But if I was to close it and then say File, New Incognito window, you go to localhost 2000, and I would get a new burner wallet, right? So it's this cool instance of a new wallet, right? So let's get some funds and let's try to change this to hack on chain like this. And let's hit send. It's going to tell me that I'm not the boss because I've kind of implemented this really like poor access control, but I've said that unless you're the boss, you cannot access this set purpose. But if I come over here, hack on chain like this, hit send, it lets me, okay? Because I have this kind of access control. But that's actually not the proper way to do access control. The proper way to do access control is actually to utilize what's called ownable. So let's get rid of that for right now. I'm just kind of showing you how we do some iterating of the smart contract. And let's get rid of this one here. And instead, let's go ahead and you'll see that you can do an import. So earlier we talked about importing the hard hat console, which allows us to print to this like pretty kind of console logging here. And that's what we do here, console log, right? We log the purpose. But we can also import Open Zeppelin smart contracts. And more specifically, we can import ownable.sol. Ownable.sol is a kind of like de facto way for you to deploy a smart contract that has access control. So we can import that, and then we can inherit that by saying that our existing contract is ownable, right? So we're going to import it and inherit it. And when we do that, let's see what happens. Let's just do our deployment again. Okay. And let's see what happens. Okay. So we still have our owner. Now we have an owner variable, which is here. And we notice we have a couple other functions. We have transfer ownership, and we also have renounce ownership. Okay, so these are inherited functions that we've inherited from ownable. One allows us to transfer the ownership of the smart contract. One allows us to just completely renounce our ownership and strip away the owner. And then we automatically have an owner here, but you'll notice it does not match our address here. It also doesn't match our address here. So where is this address coming from? Well, when you deploy your smart contract with hard hat, there's a script that does this, okay? So we can come into that script. It's in the deploy folder, and it's right below the contracts folder. Here it is, deploy your contract. And we can see that we're using ethers to define the chain, and then we're doing a setting a variable called deployer, which is getting the named accounts from hard hat here, and it's grabbing the very first one, and it's using that as our deploy mechanism, okay? So it's using that first one as the deployer, and we can see here that we get a copy of our contract and deploy the contract, okay? And so what we can do now is, since we have access to this particular, this particular function, transfer ownership function, we can now call that function. And so you can see here, we have it already written out. Actually, it's grayed out here. And we can do, because we get a copy of our contract here, we can also call that transfer ownership, and then we can paste in any address that we want to send that to. So if we wanted to, we could grab this address up here that we've been working with as kind of our like owner contract or owner address, and we can paste that in like that. So, and by the way, if you ever want to send any arguments across to the constructor, you can also do that here as well. So you can say like, I don't know, this is Dogecoin or something like that. And then you can do like a supply or something like that. We're not going to do that right now, but that's just to show you how you would pass in arguments to the constructor. Okay, so now we should be able to save this, and then let's go ahead and redeploy, okay? See if it was successful, which it was. And so now there we go. So now we have access to the owner again. We have that. Here's the particular public key. The owner matches, so we're good. So now we could, if we wanted to, over here, we could say renounce ownership, and we could get rid of the owner because we were the owner, so we were able to renounce our ownership. Now we lost access, so we'll have to redeploy again. So let's go ahead and do that. Okay, cool. So we're good to go. We could also transfer the ownership, so we could transfer it to this guy if we wanted to. So let's try that. Send. There we go. So now this guy's the owner. So if I hit refresh, and he's the owner of this contract, then I could transfer it back if I wanted to. So I've got some cool control now where I can like transfer around the ownership of the contract and whatnot. Okay, so that's cool. We've set up access control the proper way, but what else can we do that's a little bit more interesting? So we could, earlier we had this as kind of had to be the owner to do that. Doesn't really make sense to just have one function that only the owner can call. So instead what we can do is start thinking about, well, maybe we want to, since this is a payable function, maybe we should make people pay a little money to change this purpose. So let's do that. Let's do uint. So let's define a new uint variable, publicly available, called price. And we'll set it to 0.001, actually 0.1 ether like this. And you can see here that my IDE or my editor has told me how much ether is equal to how much whey. So you can type in ether here, or you can type in whey, and it's going to know the difference. But obviously ether is easier to read, so I would recommend writing in ether. And it's just, I think it makes more sense. But we're going to get to the front end here in a little bit. But let's just set that price like that. So now we can do a require statement like this. And now we have access again to those global variables. So we can say, well, let's make sure that the message.value is equal to price. Otherwise, you need to send me more money like this. Okay. So now we have a variable. We're requiring that someone pays some value on this purpose. Let's save that and let's redeploy. Okay, so that was successful. So now we have this new price variable, and we could require that someone pays that value at this point. So in order to change this to hack on chain like this, and I hit send, it's going to say, well, I need to send some money, right? So let's require that it sends some value. So we could just grab, we know it's going to be 0.01. So let's put that here. And we'll see that there's this cool little green button here. And what this is going to do for you is it's going to do the math to convert your ether into whey. So you wouldn't want your user to have to type in the whey amount, which is this long string, but that button's really nice because it just allows you to do that on the fly. And it allows you to kind of get an understanding of how you need to make this kind of like translation. Everything you're always going to do is going to be in whey, but you also don't want your user to have to type in this long string of zeros. And so you need to come up with a function in your app to do that. So this just shows you that you can multiply it times 10 to the 18th power. You probably would want to use ethers.js to do that, which can do the conversion for you. You can also convert to hex as well. So now let's hit send, and boom. So now we were able to put a transaction in, we were able to change it, and then what do we see now? Well, now we see that this contract has gotten some value. So it's actually receiving, the smart contract's acting as a bank. But there's one issue. We don't have any way to get the money out of the contract. We have the money getting into the contract. So if someone else come over here and said, like, hello world, and I put in this amount, convert it, send. So, oh, I don't have any gas, so I need to get more funds. So I can grab this, get some more funds. Let's do $100. And now let's try it again. There we go. Now it worked. So now our contracts actually has some utility. It's receiving some value, but the money is kind of stuck in the contract at this point because we don't have a withdraw function. So let's do that. Let's create a withdraw function. Okay. Let's come down here. Let's make it a new function. We will call it withdraw, and we're gonna make it public like this. And we're gonna do a couple things. First we're gonna set a boolean called success. Otherwise we won't. And if that's Boolean successful, success will look like this. It will be a message.sender. So the person who's calling the function, we will do a call. So a call is anytime you're sending value from a smart contract to an externally owned account, you should use call, and you just need to pass in the value as this kind of like JSON object. And so we're going to do value, and we're going to say address of this smart contract, and we're going to take the balance. So we're going to basically drain everything that's in the smart contract, and then we need to do that. Okay, so this should allow us to set a Boolean success and withdraw the value from the contract. But the most important thing here is now, since we have access to ownable, we can call what's called a modifier, and we can call the only owner modifier. Okay. Again, I told you before that if you invoke a smart contract or inherit a smart contract, you get access to all the functions, you get access to all the variables, and you get also access to any kind of modifiers. And so this is a modifier that checks for access control of the owner. And so we can set that up with one little modifier. So let's save that, which I think that should be good. And let's go ahead and redeploy. Okay, so we're good. It worked. So now we can come over here and say, Kevin is cool or something like that, hit send. And then we can come over here like, no, I am cool. So, people are kind of interacting with your smart contract. The smart contract has some value. And so now what do we see here? So we see that there's a withdraw function right here on the bottom, right? And so if I'm on this kind of little green blocky dude, purple blocky dude, I can say withdraw, and it's going to say, nope, I'm not the owner because I am not the owner of the smart contract. It's not going to allow me to get those funds out. But now that I am over here and it does match the owner, then I can say, all right, well, let's get the funds out of there. And it was successful, and those funds went directly into my wallet. So we've been able to kind of build some utility in our smart contract. It's acting as a bank, and we're good to go. Okay, so now what we could do is just one small little change, which is quite interesting. So we do have this price variable. Like maybe we want to make it like scalable. All right, maybe every time that someone calls a function, we want to take the price and set the price to price equal price times 101 divided by 100. So we can do it by 1% increase. So I can save that, redeploy my changes again. Here we go. And then now, if we come over here and say, this is Kevin, and send the value, and paste it in, and hit send. Oh, sorry, I need to convert, send. There we go. So now what do we see that happened? Well, we were able to deposit the thing, but guess what? The price increased by 1%. So now we need to convert it again and figure out what that is. There's the price, like, yo, send. There it goes. Now it increased another 1%. And so we've created this with one little extra line in our smart contract. We created this kind of like dynamic scaling price. That's the price is slowly going to go up as people start interacting with my smart contract, right? So that's cool. So let's just assume that you've kind of started to build your where you want to publish your DApp to a test net. Okay. As of this time, we've been using all localhost development, right? At this point, we're on localhost. We're using everything localhost. So the first thing you want to do is we don't want to use the address that comes with Hardhat because it's a shared address and all of the private keys are shared on that. So the first thing you want to do is do a yarn run generate. Okay, so yarn run generate is going to generate a deployer mnemonic, basically a deployer account, and it's going to set that up for you to be the deployer. So the address is here. So this is where we're going to want to send some funds on a test net. So we're going to deploy to BUIDL, and more importantly, I have some funds on my wallet here, my Punk wallet. And so what I can do is I can say, all right, well, I want to send, let's do ETH. I want to just send 0.05 ETH or something like that. I can do yarn account, and I have access to a little scanner here on my thing, so I can just do yarn account, and then I can scan this QR code. Okay, so now I have the QR code for the account. I can send some ETH. Let's go ahead and do that on Goerli. Let's get that rolling. So let's see if it's successful. Might take a second. You can also like copy this address here. Oh, looks like that didn't work. Let's try it again. 0.1. Hopefully I have enough. Okay. Anyways, so this address here, we could also send some ETH from like MetaMask too. So let's do that. Just because I think this might not work. I'm not sure why, but let's come over here. Let's go to MetaMask. Let's come here and let's go to the right network. So we're going to go to we're going to use Goerli. So we're going to go to Goerli, and yeah, for some reason my Punk wallet's not working, but that's okay. So we have some ETH on Goerli. So let's go ahead and send some over. So let's send to this address, which is our deployer account, and let's send 0.05 ETH, something like that, and hit next. And okay, here we go, confirm. Okay, so it's pending right now. So we'll go ahead and let that sit. So now that we have the account, we can do another yarn account. Let's see if it was successful. It might take a second for that ETH to come over. There we go. Okay, so now we have a balance. So when you do yarn account, it's going to tell you what your balance is on all of the nets. And so we have some ETH on Goerli. So the next thing we want to do is we can just do a yarn deploy, but we can do -- network Goerli like this. So with one simple change there to the deploy command, we can package up our contract, compile it down, and send it over to Goerli. Okay, and then while that's doing that, it's going to take just a second to do. Obviously, the test nets are a little bit slower, so let's just kind of let that sit a second. But while we're doing that, we can also, there it goes, it was deployed successfully, told us how much gas it took. And now what we can do is we can update our front end. So we've kind of been doing everything in React from now, or from this point on. But now we want to go into our packages, React app, source, and then go to app.jsx. And this is kind of like the main application for Scaffold-ETH. And what's important is this very, very top variable that we define is the default network. So we can change this to Goerli as well. So let's save that. And then let's come over here and refresh our app. And so now we're on Goerli. We can see here that we successfully deployed our smart contract to Goerli as well. And we're also connected to Goerli here. So we can say connect, and we can put MetaMask here. And so now we have access to our MetaMask account with Goerli as well. So now we could start interacting if we wanted to. We could send in some funds, and we can say Kevin is cool, and we can make a transaction on Goerli. So let's hit that and hit send. Okay, so as this is doing it, I just sent a transaction. So you'll see it's a little bit slower because we're on a test net, right? Transaction is started, and we have the smart contract deployed to Goerli, and then so now we should be able to hit refresh, and we should see that our new variable has been set. There we go, Kevin is cool. So we've made a transaction as well using our MetaMask integration, right? The next thing you're going to want to probably do is ship your front end as well. And so in order to ship your front end, you're going to do a yarn build, which is going to take a copy of all of your React code, and it's going to kind of optimize it and build it to be able to deploy. And then we're going to let that sit for a second, and that's going to get you set up. While that's doing that, I want to show off a little bit more of React. So we changed the default network for the front end, But the next thing we want to look at is the views. So inside of the views, we talked about it earlier, but there was the home JSX file. So this is where you would kind of like build out your application. So all of the examples that are in those kind of comments are all listed right here. So you could just get rid of all this stuff here and start building your app here, okay? So if I save that and we hit refresh and go back to app home, we could see here, build app here, right? And so this is kind of where you'll start building your app. The example UI also has a lot of different examples, which we can click here and see what those look like. Like one is just what the purpose is, one is to change the purpose, one is like what an address looks like, what an ENS address looks like, how to get a balance from an address in either ETH or in US dollars, and so how we're kind of calling the gas station as well. And then we can see here that we have like some buttons as well, some events. So I talked about events earlier. Like if you have an event in your smart contract, you would probably parse your event in some way. This tells you exactly how to do that. And then there's all sorts of Ant design stuff as well, like buttons and toggles and little switches and stuff like that, that come as well inside of this kind of example UI. And that's what's in here. Hints is exactly that. It's kind of like, oh, okay, like here's a token picker, here's a scanner for if you're using a mobile phone, how to like scan in a QR code. So there's lots of little interesting things in here on kind of how you do that. And so let's see if our build's done. Okay, so our build was successful. So we could do this to like yarn IPFS, or we could do it to yarn surge. I'm going to use yarn surge because it's a little easier, but if we wanted to, we could deploy our app to IPFS. I'm going to use surge. Surge is kind of like a hosted static file service. And so I've already gone ahead and logged in here. So if I was to come here and say hack on chain, I don't know, demo, something like that, .surge.sh, it's going to bundle up my app and it's going to upload it to Surge. So at this point, I should have access to this domain. There we go. So let's grab it and come over here. Boom. There we go. So now our app is completely basically deployed. We've deployed the app as Goerli. We have a copy of our contract. You can see here that now we have the function. So any of you guys at home or at the hackathon could go to hackonchaindemo.surge.sh and you could interact with my smart contract. And if you put any ETH in there, I'll be able to get it out because I am the owner. Oh, wait a minute. I actually lost the owner because we can see here that I just closed out the account, but we could do it. I think I should still have access here. Let's see. Let me log out. Oh, yeah, I do. So I could transfer the ownership. I could do it to, I don't know, I could transfer it to, let's do that real quick. Let's see if it lets us. Let's grab this address and let's do contracts. And then let's do transfer ownership to an account that I own. Started. See if it lets me. There we go, succeeded. So now I should have access to the owner. There we go, cryptomaster.eth now owns the smart contract. So, okay, so that's kind of where you go to after you deploy your application. I want to show one more thing, and this is your testing. So I'm going to show you, there's a test folder here under hard hat, and here's my test. So there is a chai hard hat test that you can essentially use. There's one that's already written for the hello purpose world or hello purpose set purpose function. Sorry, the hello world smart contract. And so obviously, as you start testing, your smart contracts changes, you're going to want to kind of include those here. If you do a yarn test, it will call this test. It uses hard hat chai. And so you'll see here we're going to fail because we've made some contracts that are payable and we don't have any way to send value yet in our test. So that would be like one of our next steps is we would say, okay, well, we probably want to actually send some value along with those tests. So I'm not going to actually write the test right now, but it's just kind of a good thing to know on how you can test. Okay, what else can I show? Oh, you might want to also verify your contract because it's just kind of a general practice that you should verify your smart contract. And so there is also a yarn verify command. Um, so we can just do yarn verify. Oh, and then we need to pass in the address. So we could do yarn verify, grab the address of the smart contract. And I think we can paste that along with the yarn verify. And then we can do network squarely. I think this should work. Let's see if it works. There we go. So what it does is it takes our contract, it compiles it, and then it sends it over to Goerli, and then we can see if it was successfully verified, which it looks like it was. So let's check it real quick. There we go. Cool. So we have our contract deployed. We have some value in it. It's got a balance because we updated the thing, and then we have the contract here available as well as a verified contract. So you can see how easy that is. You just do a yarn verify, pass the address of the smart contract, and then what network you want to verify it on. Okay. Okay, cool. So yes, that is pretty much my walkthrough. I hope you guys found that useful. Um, if you guys have any issues or if you get stuck, please, click this link right here, scan this link. Again, this has the Telegram channel. This has the repo, the docs. I'll also be available. It's a little bit early right now, so I won't be online for a little bit. But if you guys have issues and you get stuck, you can find me on Telegram. My Telegram handle is Kevin Jones Creates, and on Twitter I am CryptoMastery_. So I thank you guys so much for your time, and I hope you guys have a good hackathon and good luck hacking.